Hi students, I'm Praveen Sebastian Paul. In this lecture, we are discussing a bridge rectifier. So the rectifiers are mainly classified into three types. They are half-wave rectifier, center-tapped full-wave rectifier, and a bridge rectifier. All these three rectifiers have a common aim, that is to convert the AC signal into a DC signal. Not all these three rectifiers efficiently convert the AC into a DC. Only the center-tapped full-wave rectifier and the bridge rectifier efficiently converts the AC into a DC. In the half-wave rectifier, only one half cycle is allowed and the remaining half cycle is blocked. As a result, nearly half of the applied power is wasted in the half-wave rectifier. In addition to this, the output current or voltage produced by the half-wave rectifier is not pure DC but a pulsating DC, which is not much useful. In order to overcome this problem, full-wave rectifiers are introduced. The main advantage of the center-tapped full-wave rectifier is that it allows the electric current during both positive and negative half cycle of the input AC signal. As a result, the DC output of the center-tapped full-wave rectifier is double as that of the half-wave rectifier. In addition to this, the DC output of the center-tapped full-wave rectifier contains very few ripples. As a result, the DC output of the center-tapped full-wave rectifier is smoother than the half-wave rectifier. However, the center-tapped full-wave rectifier has one drawback, that it is a center-tapped transformer used in it is very expensive and occupies large space. To cut this extra cost, a new type of rectifier known as a bridge rectifier is introduced. In bridge rectifier, the center tapping concept or center tapped transformer is not required. Even if the stepping down or stepping up of voltage is not required, then even the transformer itself can be eliminated in the bridge rectifier concept. The rectifier efficiency of a bridge rectifier is almost equal to the center tap full wave rectifier. The only advantage of the bridge rectifier over the center tapped full wave rectifier is the reduction in cost. In bridge rectifier, instead of using a center tapped transformer, 4 diodes are used. When it comes to the definition of a bridge rectifier is a type of full wave rectifier which uses 4 or more diode in a bridge circuit configuration to efficiently convert the alternating current into a direct current. The construction diagram of a bridge rectifier is shown in this figure. The bridge rectifier is made up of 4 diodes, namely D1, D2, D3 and D4, and there is a load resistor RL. The 4 diodes are connected in a closed loop. This loop is known as a bridge. So this configuration is to efficiently convert the alternating current into a direct current. The main advantage of the bridge circuit configuration is that we do not require an expensive center tap transformer, thereby reduce the cost. So the input AC signal is applied across the two terminals, terminal A and terminal B, and the output DC signal is obtained across the load resistor RL, which is connected between the terminal C and D. The 4 diode D1, D2, D3 and D4 are arranged in series with only 2 diodes allowing the electric current during the half cycle. So when it comes to the working principle of a bridge rectifier, when the input AC signal is applied across the bridge rectifier, during the positive half cycle, the diode D1 and diode D3 are forward biased and it allows the electric current, while the diode D2 and D4 are reverse biased and blocks the electric current. On the other hand, during the negative half cycle, the diode D2 and D4 are forward biased and the diode D1 and D3 are reverse biased. Thus, the D2 and D4 allows the electric current while the other two blocks the electric current. During the positive half cycle, the terminal A becomes positive while the terminal B becomes negative. This causes the diode D1, D3 forward biased At the same time, it causes the diode D2, D4 at reverse biased condition. The current flows in the direction during the positive half cycle is as A to D, D to C, and C to B. During the negative half cycle, the terminal B becomes positive while the terminal A becomes negative. This causes the diode D2 and D4 as forward biased. At the same time, it causes the diode D1 and D3 as reverse biased. The current flow direction in the negative half cycle is as B to D, D to C, and C to A. From these two figures, we can observe that the direction of the current flow across the load resistor RL is same during the positive half cycle and negative half cycle. Therefore, the polarity of the output DC is same for both positive and negative half cycle. The output DC signal polarity may be either completely positive or completely negative. In our condition, we are considering it as a completely positive cycle. If the direction of the diode is reversed, then we get a complete negative DC voltage. Thus, the bridge rectifier allows the electric current during positive and negative half cycle of the input AC signal, and the output waveform of the bridge rectifier is shown in this figure. So my dear students, this is the working of a bridge rectifier. So as we mentioned, a rectifier is used to convert an AC signal into DC one, and a bridge rectifier is a full wave rectifier which is introduced with the help of diodes only in order to reduce the cost without using a center tapped transformer. So my dear students, hope you had understood this topic. So dear students, kindly write down this assignment question. Our question is, write notes on bridge rectifier. So dear students, see you soon in the upcoming lecture. We will discuss a filter circuit in a bridge rectifier. So dear students, see you soon. Until then, goodbye. Thank you and all the best.